Hello. Today we're going to talk about learning to see why materials look the way they look. And in order to learn that, the first thing we need to understand is the process of seeing. What is it that causes us to see materials? And why do so many materials look so different from each other? And why do some look similar to each other? And why are there properties in some that are the same in the others? If there's so many different things in the world, why are they not all different? They don't all look different. The process is simple. Light emits from a light source, hits some molecules on a material, and then bounces into our eye. It's as simple as that. The question is, why do things look different? And the answer to that is actually really very simple too. If you can switch your brain to think of materials only in terms of the reflection of light, then you'll begin to understand how simple light and materials really are. Just put this in your head and you'll start to understand it as we go through these images. Everything that you see is nothing more than the reflection of light. Okay, so let's begin. With this first image, we're looking at a photograph of a bathroom mirror. It's pretty straightforward. Most artists will look at that and say, well, yeah, that mirror material is reflective. I can see that it's reflective because I can see the reflection in the mirror. Therefore, yes, it's reflective. Most people look at the wall and the wood around here and say, well, no, not really reflective. Maybe this is a little bit reflective up here, but this is not reflective down here. Well, one has to wonder how that can be true. If this is the same wood material, why would it be reflective here and not here? If it's reflective here, it's reflective here. But the truth is that everything that you see is reflective. It's all reflecting light. The difference is this somehow maintains the structure of the light that's reflecting off of it, and this wall over here does not. And this wood in the middle does somewhat. We can see 3 lamps above the mirror, but they're kind of blurry. So this wood somehow maintains some of the structure of the light that's reflecting off of it. And this mirrored material somehow maintains seemingly all of the structure of the light that's reflecting off of it. And this wall, well, we can't see any images there at all. So while there's light clearly reflecting off of it, we don't see any images. So the structure of that reflection is lost. Okay, let's look at the next image to support this. So in this image, I put a white card in front of the mirror. Same lights are on, and the piece of paper is white, the card is white. So if we look at the mirror, we'd probably say the mirror is reflecting 100% of the light. Well, theoretically, and in reality, there's probably some small amounts of visible light that aren't reflecting, but most of the light. Let's say 100% just for the sake of arguments and ease of mathematics. When we look at the white piece of paper, how much light is reflecting off of it? Well, it's white. Therefore, by nature, it must be reflecting all of the light that's shining onto it. Again, technically, probably not 100%. Probably some of it is bleeding into the surface. But for the sake of ease of mathematics, again, let's say 100%. Well, if the mirror and the piece of paper are both reflecting light 100%, why do they look so different? What can be different about these things? They're both reflecting light 100%. The answer is simple. Specularity. When I refer to specularity, I'm not talking about specular highlights that we talk about in CG. I'm talking about the real-world definition of specularity. And specularity simply means smoothness. Something that is very, very smooth is highly specular. All right? This mirror has silver attached onto the back of it, and attached onto the back of the glass, and the glass is incredibly smooth, very, very highly specular. And because the molten silver was poured onto the back of the glass, it too is incredibly highly specular. And because it's highly specular, because it's very smooth, the light retains its structure. Whereas with the paper at a microscopic level is extremely fibrous and rough. It's not very specular at all. And therefore, light is diffused into many different directions. Let me just do a little drawing to show you what I mean by that. Okay. If we have a piece of glass, for example, with silver painted on the back of it, we have light coming in. For example, at this angle. Because the glass is perfectly flat, the angle that the light ray hits the glass is going to be the same as the angle that it reflects at. So what we're saying is this is perpendicular. The angle of incidence equals the angle of reflection, for those of you who remember your grade 9 physics. Okay? So the structure of the light that's leaving is going to be the same as the structure that's coming in, except now that it's backwards. You see the order of these rays has changed. Okay? This is why things appear backwards in a mirror. Because the plane that all the light rays hit is exactly the same, the angle that the light rays leave is all exactly the same. Now, for example, imagine you're looking at that piece of card at a microscopic level. It's extremely fibrous and rough under a microscope. It feels smooth to our hands, but photons are very small, and therefore they see all the imperfections in that piece of paper. Okay, so this is our piece of paper down here. The surface of our piece of paper. Let's say we have the same light rays coming in. Okay. This one, again, it's going to be angle of incidence equals angle of reflection. So this one's going to come in, it's going to hit here, it's going to bounce there, it's going to bounce there, there, and then there. This one's going to come in, it's going to hit here, and go back that way. This one's going to come in here, it's going to hit kind of like that, it's going to go like that. Let's draw a couple more in here just so I can show you what I mean. This one will bounce back here. This one will go bing, bing, bing. So you can see, if you look at all the outgoing angles, you can see they're all spread out. We call this diffused. So on the surface of a very rough material, the light rays get diffused. And on the surface of a very smooth material, the light rays get not diffused. And as you go in between smooth and rough, you get different levels of diffused light. When we have a material that's not quite smooth but almost smooth, we see a reflection, but it looks blurry. In CG we tend to call this blurry reflection. But the fact is that the light on a highly polished piece of wood that's kind of a blurry reflection is the same light that's on a carpet where you can't see any reflection at all. It's all reflected light. The only difference is how smooth the material is. Now here's another interesting point about this. In CG we have something called specular highlights. We see these on plastic and on skin and on actually most materials. We see something called a specular highlight, and we think of this in CG as specularity. But what it is reflection. It's a reflected highlight, usually from a nearby light source or whatever the brightest thing nearby is. Usually makes a specular highlight. And since specularity and specular highlights are reflections, and since everything reflects, we need to understand that everything in the real world has a specular highlight. We know that as materials get smoother and smoother, the specular highlight gets smaller and smaller. On materials that are very rough, we think, well, that doesn't have a specular highlight. That's not true. As things get rougher and rougher, the specular highlight just gets larger and larger. Sometimes it's so large that we simply can't see it at our scale. For example, if you have shag carpet, you're not going to see much of a specular highlight on it. But if you filled a stadium with shag carpet and sat way up in the back of the bleachers and the sun was out, you would definitely see a round specular highlight from the sun on that shag carpet. It's just so big that you can't see it at the scale of one room. The reason is it's a reflection of the sun. The shag carpet is simply so rough that the reflection of the sun is enormously huge. Okay, moving on with our imagery here. Here's another example of reflection. This is one of those hand blow dryers in a swimming pool change room. And we look at this and we say, again, this is very highly reflective. And before today we may have said this is not reflective, but it has a specular highlight, and this wall is not reflective. The fact is, it's all reflective. It's all reflecting light. Some of it is more highly specular than others. See the orange shirt here? If you look carefully, you'll see a little bit of orange tint down here. See the lights up here? If you look carefully, you'll see the lights reflected up here. These are reflections. Specular highlights are reflections. Seeing anything is a reflection of light, unless you're looking directly at a light source. That's not a reflection, obviously. That's an emission of photons. Okay, here's some more metal. Okay, this is what we're talking about, kind of a blurry reflection. You kind of see some of the detail. There's my orange shirt again. You can see some sharp lines, but it's really dirty, and it's kind of, the interesting thing is this is brushed metal, and it's brushed in this direction, so the reflections are soft they're blurry along this axis, but sharp along this axis. That's one of the manifestations of brushed metal. And if you look at, so this is a change room locker, if you look at the outside of the locker, which is made of the same metal, it actually appears to be what we would say less reflective. Of course, we now know it's not less reflective, it's simply rougher. Okay, the metal has a pattern on it, some pattern that's built into it, and it's quite rough. But even still, we can see some detail of the surrounding environment in those reflections. So we would never be able to make this material without some kind of reflection. It would never look right. Here's a really interesting thing about blurry or soft reflections. We've discussed in other portions of these videos that natural shadows are very sharp near the object that's casting them, and they get softer further away. Well, that's true of reflections as well. Reflections are, if you put something right on something that's rough, you'll see it reflected most sharply right where the object touches it and getting blurry a little further along. Okay, so this is some aggregate concrete, and it doesn't appear to be very mirror-like. It's very rough and is therefore not very specular. All we have to do to make this more specular is to make it smoother. Well, how might we do that? Well, add a little water. All of a sudden, it's extremely highly specular. The reason is because all of that roughness, or a lot of the roughness, has been filled in with something with a smaller molecular size, in this case water. Okay? So this is a really good example showing that specularity, smoothness, is all about filling in those rough holes. And that's what creates what we think of as image reflectivity. Okay, Speaking of specular highlights, this is a piece of carpet, and it's not very shag-like. It's a pretty low pile carpet, and because it's a low pile carpet, we can see a light highlight in one corner. And this is a specular highlight on a carpet. If we stood even further back, it would be even more clear. Okay? So even something as rough as a carpet has a specular highlight. If we were to take this carpet and douse it with water so that it was filled up, we would all of a sudden start to see the image of a window appearing right over here. And the difference between this carpet and this carpet, if it was wet, has nothing to do with the reflective amount of the material. Remember, this carpet is reflecting the same amount of light whether it's dry or wet. It is equally reflective regardless of how smooth it is. Specularity has nothing to do with the amount of light that's reflecting off of it. Specularity is smoothness. Now we have our shag carpet. It's positioned similarly. However, it's very difficult to see a specular highlight. We can sort of see a little bit of extra intensity in this corner, but in this case, the material is so rough, the specular highlight is, in other words, the reflective image information is spread out so wide that it's nearly undetectable on this material. But it still exists. Once again, if we were to take this and cover the field of a football stadium with it and sit up in the bleachers, we would very, very clearly see the specular highlight even on something as rough as this. Okay, denim. A typical example of a rough material you see in the world. We're not going to see a nice round little specular highlight on this because the material is very irregular in shape, so we start looking for other highlights. Right? We see highlights along edges. Those are reflective or specular highlights. And this cloth material is reflecting the same amount of light that would be reflecting if a mirror was sitting here, except for the fact that it's blue, so therefore it's absorbing, some of the red and green light, a lot of the red and green light. Okay, so here we have kind of a faux satin here, and if you look at the difference between these two materials, you can see this one is very rough looking and this one's very smooth looking, and the reason is this one has a much looser weave made out of much thicker thread, and this one has a much finer weave made out of much thinner thread. And the result is that this material is much smoother, much more highly specular than the other material, and therefore we see specular highlights very easily along all the edges. And if we were able to resolve these into images, we would see that these are simply reflections of the lights that are above this material illuminating it. This is a similar idea. This is a velour. The difference is, rather than seeing the weave of the fabric, this is a whole bunch of fibers sticking out. And the interesting thing is you only get specular highlights where you see the edges of the fibers. Where you see the fibers end on, it falls into near blackness, which is a particularly interesting feature of a material like this. It'd be quite difficult to make a velour material without either a very, very tight displacement or some kind of a fur shader or something. Okay, so a wet floor once again at the pool change room. We can see in areas where the tile is dry, it appears to have very low reflectivity, very low specularity rather. And in areas where it's wet, we can actually see that there's a light source directly overhead that's roughly rectangular. Okay, so simply by putting water on the tiles, all that does is make them smoother. It fills in the microscopic roughness of the porcelain tiles and makes them smoother. Alright, water. So what we're seeing here is, we know pool water is not a flat plane, it's quite highly displaced, it's moving all the time. We can see here 1, 2, 3 light sources overhead that are being reflected in the water. And additionally, we can also see the caustic effect. This is light refraction. Because the surface of the water is wavy, it's acting like multiple variable lenses, and it focuses light into tight areas on the bottom of the pool. And by the way, don't forget that if you're thinking about caustics, light that is focused towards somewhere also has to be focused away from somewhere else, which is why you'll notice that if you ever see a caustic highlight, you notice that the area around the caustic highlight is actually dimmer than everywhere else. The light is focused away from some areas and into other areas. Okay, so some areas get brighter and some areas get even darker than the normal room light. That's just a little aside on caustics. Okay, so talking about reflection again, we can see if we look along the edges here, we can see along the edges of the waves areas of more darkness. Okay, those are areas where we're starting to see some more reflection. Some people refer to this as the Fresnel effect, which is the increasing density of light or light reflection based on the incidence angle to the camera. That's actually a whole topic of its own, and we'll get into that in other sections. Just know this though, many artists will use a ramp to increase the reflectivity of a material based on its incidence angle to the camera, which in effect means you're changing the material properties based on where the camera is. So you need to ask yourself this question: does this water's material properties change based on its incidence angle to the camera? Yes or no? If you think about it for a minute, the answer logically has to be, well, of course not. The water doesn't change its chemical properties based on where I'm standing looking at it. Of course it doesn't. So the next question needs to be, do I need a Fresnel shader to change the reflective quality of water based on the incidence angle to the camera? Or maybe am I missing something? Is there something else I should be considering? It's an interesting question. Once we get into looking at building materials, we'll be using specific terminology about good and bad materials, and what we'll be saying is valid and invalid materials. And valid materials are materials that are based on the physical laws of lighting materials in the universe. They don't necessarily actually physically obey those laws, because we are working in CG, which isn't physically correct, but they're based on those with an understanding of them. And because they're based on physical law, they should work, just work, no matter what you put them on and no matter what the lighting condition is. Conversely, an invalid material is a material that may look good at a certain specific camera angle or under certain lighting conditions, but once you change those conditions, the material looks wrong. This is called an invalid material, and it's invalid because it doesn't actually work. It may appear to work in one specific instance, but there's no reason at all that materials can't be made to work in all circumstances. And while it does take a little bit more understanding and effort to create a valid material than it often does an invalid material, it's actually a great time saver over the long run, because you'll find that shot to shot you won't have to continually readjust your textures. If you're creating invalid materials, you'll find yourself spending much more time and effort doing texture work than if you take a little bit of extra effort up front to create valid materials. But we'll be talking about that later on. Okay. Again, here we have an interesting look at some porcelain tiles, and some of them seem to have this specular highlight on them, and some of them, well, these have a specular highlight too, but it's a little bit different, isn't it? It's a little bit softer. It's a blurrier reflection. Once again, that's based on the fact that the glaze used on the white tiles comes out a little bit rougher, a little bit less specular than the glaze used on the black tiles. And then, of course, the grout in between is much rougher, so you can't see any specular highlight at all on there. The fact is that all three of these materials are reflective. We know they're reflective because if they were not reflecting light, we would not be able to see them. All right? And actually, that's an interesting point. We look at the black tiles and we see that they're almost black, which means they're reflecting very little light. Mainly, they're defined by their specular highlights. There's a little bit of reflection on them, but mainly they're defined by their specular highlights, and they actually reflect very little of the light that's hitting them. That's what makes them black. And therefore, that means that this material is absorbing most of the light that hits it. And the white tiles, conversely, are white because they're reflecting most of the light that hits them and absorbing very little of the light that hits them. Okay, more porcelain tiles. In these ones you can see not only the specular highlights like you did on the black ones, you can also actually see the image reflection of those three lamps that are over the mirror in the background. Okay, so this is a very highly specular surface, not as quite as specular as a mirror, but very highly specular. In other words, very, very smoothly polished. It's the glazing that has turned out very, very smooth. Okay, a piece of aluminum foil. So this aluminum foil, this side of the aluminum foil here isn't the really super shiny side. I flipped it over because I wanted to look at the blurry reflection side. So I have a lamp over on this side, and on the left hand side, and on the right hand side there's a window with skylight coming in. We can see the blue light from the sky over on this side. We can see the warm light from the incandescent light on this bulb. We can't actually quite see any imagery in here, but the specular highlights, the reflective highlights, are all quite tight, indicating that this is a fairly highly specular, in other words, fairly highly smoothed material. All right. If we look at the paper right beside it, it has exactly the same light on it as the aluminum foil, but we don't see that because the paper, by contrast, at a microscopic level, is much, much rougher than the aluminum foil. Okay, here's another example of a water filling in the roughness and creating high specularity and therefore reflective imagery. All right. So, but let's look at this and say, well, how reflective is this? Many people will look at it and go, well, it's water, it's made smooth, and it's glassy, therefore it's 100% reflective. It's 100% reflective because we can see the image. Well, I think that needs to be rethought, because if this image down here were 100% reflective, then the brightness here should be equal to the brightness here. We see white here, close to white. We don't see that here. We see darkness. It's almost like a shadow. So the amount of light that's reflecting down here is quite a lot less than the amount of light that's reflecting here. In fact, some of the light that's hitting this, because the water is transparent, some of the light that's hitting the surface is going through the water, hitting the decking underneath it, and diffusing. Some of the light is hitting the surface of the water and reflecting. And some of the light is hitting the deck and absorbing. So the light is going a lot of different places. It therefore is clear that this surface cannot be 100% reflective. And this is actually a good place for us to start thinking of the difference between reflected light and diffuse reflected light. So let's add that to our definitions. We've been talking about reflected light as all light that is reflected, and I think now is a good time to split that terminology up a little bit so that we don't get confused. So let's refer to light that is reflected as an image as reflections, and let's refer to light that is reflected without an image as diffusion or diffused reflections. All right. So, for example, the light reflecting off this fence post is diffused reflection because we can't see a reflection image. The light reflecting off this water is reflection. All right. So that's kind of circling back to our original definitions, but now with a much better understanding of what reflected light actually is. Okay. Here's another example. This is kind of halfway between reflected light and diffused reflections. We can see some shapes in here. We can see this color reflected down here. This is obviously, it's a radio and it's plastic here, and this is plastic as well, but this one is a little bit smoother and therefore it's a little bit more reflective. This one's a little bit more diffuse. Okay. In CG we might call this blurry reflections. Well, this is blurry reflections too. And here's the interesting thing. Because everything that you can see is reflecting light, and that the less amount of image you see in the reflection means that it's more blurry, it seems like it would be theoretically possible to create all visible materials out of blurry reflections. Well, except probably not transparent materials. But every normal opaque material could be made using simply blurry reflections. The only question would be, how blurry? That's food for thought. Okay. Looking at the quality of reflections, do you remember earlier I was discussing how reflections are, blurry reflections are sharper, close to where the object is that's reflecting, and they get softer and softer further away. Just like natural shadows, and in CG, just like area light shadows, or volume light shadows, spherical light shadows, what have you these days. And this is a good example of wood that's been fairly highly polished, so that it's so specular, so highly specular, that you can actually see clearly images reflected in the wood. Of course, wood comes in a lot of different forms, shapes and sizes and polishes, and it can have lots of different levels of reflectivity. Here's a chair. It's a little bit polished. We can see a specular highlight along here, but we can't really, there's another one here, we can't really see much at all in the way of image information. Here's some more wood. In this wood we can't see, well, any specular highlight or any reflected image. It's obviously not polished. In this case, this is a birch kitchen countertop, so it's quite rough. This, on the other hand, is even rougher. This is just some old construction plywood, even rougher than the birch countertop. We can't see any highlights at all, actually, on this one. On the other hand, here we have an old oak hardwood floor, and we can see a specular highlight from the light that's hanging above. And if we look closely, we can actually see the light bulb in the center of it almost. If this floor was a little bit better polished, we could probably see the actual light bulb very clearly in this specular highlight, in this reflection. Again, there's a cedar wooden door, and once again we can see a specular highlight up in the corner. It's smooth, quite smooth, and it's lacquered but not highly polished, so that what would be a reflection of the light bulb right here is spread out. It's diffused somewhat. And here is a very high, or quite highly polished piece of furniture. And because it's quite highly polished, we see very tight specular highlights, which are actually just reflections of the environment around it. We can see the window, and if you look closely, that's me right there in the reflection taking the picture. Okay. Remember that all specular highlights are reflections of the environment. Often you can get away with just a CG spec highlight, but remember this. Where you have a circumstance like this, where you have a broad area of what's supposed to be fairly smooth material, CG specular highlights are not going to do the trick. If you want it to look photoreal, you're going to have to put an environment around your material and have it be reflected in the material. Just turning on reflection won't do the trick. You need something for it to reflect. And as with metals, in order to get any kind of reflective material to start looking right, you need an environment around it to reflect, whether you build a geometric environment or put an image in the background or whatever. You really need the complexity of that background in order for your material reflections to start feeling right. Okay, that's it for our brief discussion about the nature of materials. I hope that if you have any suggestions for this video, you'll let us know. We're always trying to make adjustments and improvements to our videos so that they're as informative and educational as they possibly can be. So I hope you found this video useful. Thanks for listening.